Okay. Um, let's catch up with chat. Thunder, congrats on the first. Yeah, orange juice is just an easy answer there. I like apple juice too. They add way too much sugar to it. Orange is probably the same problem. I guess red bean just tastes better. Uh, your ability to accomplish tasks will follow with success. Not a bad fortune. That's a good fact, Jed, about granite. Just don't know what they're talking about exactly. With pulp or no? I usually go no pulp. I'm not too picky about it now though. Apple cider is pretty great. I'll give you that, as long as it's not too sweet. I think music's still a tiny bit hot. Okay. I feel like I'm forgetting something. I think I'm doing everything right. I guess we'll find out. You aren't going to be able to see it too well right now because it's a little too bright out, but you all can control my lights again. Right now they're green. If I make them blue, can you even see? Kinda, yeah. Yeah, see? So, I finally got that working again after like 9 months of being lazy. What's holding back is that these lights, they can do cooler things, like they can do little like light shows. I wasn't able to figure out how to actually do it though. So I just did the basic colors again. I always make my bed. I made my bad. Flag is not. Is it ever mirrored? It shouldn't be mirrored. Wait, is it? No, I don't know. Hey Teja, hey BR Gaming, I do. It did? I don't think so. Only the flag? Was my closet in the same place? Sorry, Joseph. I cost you your first. And hey, color cone. Um, I did mirror my camera when I was playing a non-DayZ game. What game was it? I put my camera on the right side of the screen, so I mirrored it. Maybe when I did that, I don't know. What am I studying? Bald guy. um, where so today I was planning to work on my calculus of variations homework. There was some PDs somewhere that just got posted. I don't know if I don't know if I feel brave enough to attempt it right now. I'm on for calculus of variations. I'm on number 3. There is a typo. Oh wait, I didn't answer part B right. Yeah, we're just doing like the Euler differential equation basically. Nothing too fancy yet. I'll show my PD somewhere. I've only read the first question. A function that's equal to the negative of its Laplacian. Yeah, these are almost all these are Euler Lagrange. I bet. I mean, a linear function would do the. No, it wouldn't. An exponential would do the trick. No, it wouldn't. A sine or cosine would do the trick. Yes, sine or cosine. Yeah, I guess complex exponentials. Yeah. That is an eigenvalue thing, isn't it? Um, oh, what the fuck is this? We haven't talked about any matrices in this class. Okay, well, that's gonna be fun. I have the proof from class to show that if it's harmonic and not constant, it grows at least linearly. Okay, I didn't quite understand the proof we did in class for the different version of this. The function is subharmonic if it's greater than or equal to 0. Why? Maximum principle. Ooh. Okay. 2 is change of variables. Uh... Hmm. The gradient of u. Okay, not Laplacian. I already said hi to you, Teja. Oh yeah, so uh when it comes to the music that I play on stream, I don't have a good way of like sharing it. If you ask me, I'll always link the playlist. It's not usually the same thing each time, but I'll give you the link for this one. It's just a Spotify radio for a song that I like. Uh I did link my Spotify to my Discord specifically, so I think if you click on my profile, oh, I guess the streaming thing is covering it up. Jesus H. Christ, I'm stalking myself. Okay. So you can see what song I'm currently listening to right now on my Discord, I guess. Um, so I link my Spotify to my Discord specifically so that people can at least see what I'm listening to if they're curious. Burnside's, I've heard the name of that. I don't remember what that is, though. Can I explain these terms? There's a lot of terms here. I don't know which ones you mean. These are kind of hard to just explain. It would be a very long explanation. But yeah, so I want to focus on like have some variation stuff at least for now, but we could switch into PDEs if we feel like it later. Um, okay, I do realize I need to fix my work for B. We don't care about. Well, I guess we do care about where it's equal to. We care about where it's Legendre condition. There's two. There's a regular one and a strengthened one, but it's like the second derivative test for. I guess you call it a functional instead of a function. Um, you want it to be greater than or equal to 0. But cotangent of x, it does change signs. And so finding where it's equal to 0 does help you figure out where it changes signs. It's negative. It's surely in the between pi over 2 and pi. Yeah. Just as an example, we can make this like multiples as well. Okay, that's why it may not be fulfilled. Okay, let's bring in number 3. Have you stopped being a fool post April 1st? Sorry, you're just a fool for life. Syntax. There's no escaping it. For 2 in the new coordinate, uv should tell you the Laplacian becomes u squared plus v squared. So change of variables is isometry. For every orthogonal matrix. I guess yeah. The work would be showing that the partial for du dx is some multiple of the partial dv dx. Yeah, I definitely see how that's supposed to be a change of variable. Also, am I dark? Should I turn my lighting up? Sorry. Ooh, I think it's better. Hey, Anirud. Welcome back. 3 days till it's been 30 days since I did my number theory. That's... I don't know why you're counting that syntax, but fair enough. It's going well. Anirud, how about you? And Scorpra, hello. Hope you've been good. U is not necessarily a harmonic. I don't know if we care about that. How do it without crying blood? Yeah, we don't. Okay. Oh, okay. Syntax, that makes sense. Hey, Obi, I am back. I don't know. Alternative? No, we just have the... It's just whatever the sum of the second partial derivatives. Our paper this semester from engineering mathematics tricked everyone. Is that a good thing or a bad thing, Anirud? We're all cooked? Oh, okay, that sucks. Okay, you know what? Maybe we'll do some PDEs. Since Colorcone has some thoughts on these, I might be able to get some free ideas for how to do this. Homework. The professor for this class is he's a really funny dude. Like, he's a real character, but he's also just like in his own world and doesn't really... I don't know, he assumes a lot of you. So I'm a bit nervous about how this class is going to go. Delta U is the Laplacian operator. I'm more used to saying it as like Nabla squared, but it's the sum of the second partial derivatives. So if U is 2-dimensional, it looks like this. You know, Nabla. Okay, yeah, I kind of I prefer this. Um, but it seems like once you get to a certain level of math, or it's a certain like kind of math, they start to use delta randomly. I don't really know why. Okay, so all we know is that u is a smooth function, so it's differentiable. Q is an orthogonal matrix. So if we have I'm skipping this. Why'd you make a slowed down version of a song? I don't get it. Hey, Hardlocked. Hope you're doing good. You're great. Hell yeah. Oh, you know what? The last time we talked, you mentioned you were getting ducks, right? How are the ducks doing? They're quacking? That's a good sign from what I've heard. We also got rabbits. Oh, hell yeah. How many animals are you up to? I'll bet at least 20, I feel like. A lot? Gotta set up a petting zoo or something. Oh, with my haircut? Yeah, it's a jump scare. We've talked about it. Yeah. I'm preparing for your entrances. Oh, how did they go? Uh, because I'm trying to figure out syntax error what the Laplacian of v is. So I maybe should have written a different step first. Uh, Mid? Oh, okay. I don't know why that got hidden. Laplacian is the trace of the Hessian. That makes sense. I don't know if it's quite like it's a slur now. Apparently, even calling a test mid is a slur. Look, by the second half of this year, you'll finally get the math here after I start college. Hopefully, change a variable formula for the Hessian. I don't know what that is. Maybe I should look in the textbook. Wait, did I say Fokker? Ah, Fokker. That's funny. Also, a heat ball. It's kind of funny too. Anyway, Hessian. Seriously? From Helmholtz to Hilbert, but no Hess. I wonder if they must call it by something else. Do orthogonal matrices commute? Trace does. Oh. That's strange. Why are we doing it in terms of an inverse? Big winner. Wrinkles should merely indicate where the smiles have been. That there's so that sounds like it's supposed to be a cheerful fortune, but it's not quite. Like something about that phrasing feels off. I don't go with so many Mark Twain quotes in these fortune cookies anyway. There you go. Just smile through it. Also, it might have called you old too. I don't know. I don't know why my fortune cookies are always so rude to you. um dude, I don't really even know like what this change of variables means. Like do something unusual today, pay a bill. Damn, you're getting called out, Obi. G-Hive. What's the deal with Neil Young? I mean, the guy's born in 1945. That's retirement age. Didn't he start calling himself Neil Old by now? Oh, that's a good one, Chiev. 1945, damn. You know, sometimes you gotta pull out the bong quinner. I get it. Gotta pay your weed guy. All my U.S. credit cards are languishing. Okay, I have a joint like right here on my desk, so I can't judge. Um, I don't know. Like this doesn't feel right. It should be true. Yeah, I I understand like the what you put there where like I understand that like the Laplacian is the trace of the Hessian, and I can believe you when the matrices in the trace commute. That makes sense because you only care about the diagonal, and that would just give you the trace of the Hessian. But um, I don't understand. I I I I I don't understand the change of variables formula for the Hessian part. I guess I don't know if that's understood in the context of this class either. Maybe it is. Yeah, I do partake just occasionally, but a man meets God and asks him why is speed of light that. God looks confused and says to the man, "What are you talking about? The speed of light is one." I mean, that's unironically how they do it in physics. You say the speed of light is one, and then everything is measured as a percent of that. Yeah, Calcone. I guess so. Like, this is helpful for knowing it should be a true statement. That's not something I can like turn in on my homework though, which isn't your job to like give me that. Um, I just need to keep on searching for either a way to justify that in the context of this class or finding a different argument. So okay, if I just like I still don't understand this. What I've written here. If I do like if I have f of x equals maybe x squared, so it's not too trivial. And I want to consider g of x equals f of 2x. And I want to know the derivative of g of x. Oh, wait. Well, yeah, is this even right, what I've written then? Oh, yeah, okay, no, this is the chain rule thing. Why can't I figure out how to write this, though? Um, hey, Mate. And then it's like evaluated at x equals 2x or so. That's the part that's a little bit strange to me, but what? Sure, Mate. So wait, what if I f of 2x? So g of x is 4x squared. So that's going to be 8x. Oh, yeah, I'm sorry, Mate, links aren't going to show up in chat, but I'm not sure that's something that I want to do right now. I'm sorry. Two times 2x. But we need to change this x into a 2x. So like I think I almost need like a dummy variable here. That's why it looks so weird. But this would give me 8x. I should maybe just like make it into u. That's what I'm getting confused on. So, okay. I'm going to change... I'm going to let u equals qx. No, U is a terrible choice. U is the one, like, one of the two letters I should not have chosen. Well, three. Damn it, why do mathematicians always choose the same letters for everything? Why? No, Y is also a terrible choice. God damn it. No, I'm using Y. Who cares? The coordinates are going to be x1, x2, x3. Whatever. I really need to see this basic example like actually worked out for me to make sense of this harder example. Okay, so uh then a derivative with respect to u is twice the derivative with respect to x. Okay. Wait. The derivative f of 2x is 4x squared. And then we take the derivative. I'm getting too many 2's now. God damn it. Yeah, there's like a sneaky thing where like I think these two Laplacians aren't the same operators. They're not in the same coordinates, and that's what I'm struggling with. I and like I don't think it's even like the entire problem. I think it's just like the setup of the problem, to be honest. Well, this is still in Y's. We need to make it in terms of X's though, and what I want to do is just slam a Q in front. I'm trying to justify that with my work down here, and um, I've noticed that this Q inside the parentheses is now wrong for some reason. Does it make sense? The Laplacian gives you a number. I mean, I'm trying to do the chain rule on the Laplacian operator. I haven't actually like evaluated anything yet. Oh, you mean the Q is okay? Yeah, because Q is okay. Okay, I see your point. Like it gives a scalar, not a matrix. Well, that's a problem. Mm. Well, I have no clue how this works then. Okay, uh am gonna call myself stuck on this and not do it right now, probably. I wasn't planning to do the PDEs homework right now because I didn't think I was going to make any progress. Whereas I do know what to do for the calculus of variations homework. Okay. Um, I need to. I need to get the Euler Lagrange equation tattooed on me. I can never remember it. Okay. For part A, we need to solve whatever ODE we get out of this bad boy. So the derivative of this with respect to y primes, or just y prime, 2y squared y prime Hey Winklebot, why you stream on same topic even no one watches that? Yes. How's it going, Winklebot? Then we do a product rule on this thing. Good to hear, good to hear. Ooh, I'm not doing product rule correctly. For y from that piece, but then chain rule, we get a y prime, but then we already have a y prime, so it's y prime squared. It's 2y squared y double prime. Change variable for the derivative function frn to rn. You supply the gradient to obtain the change of variable for the Hessian. I don't think I know the change of variable for the derivative of function, Carlicone. I don't think if I learned that, it was a long time ago. Students using Calc 2, things are finally making sense. Awesome. Glad to hear it. Those are good to know. So this ODE, it kind of sucks balls. But we're already given that to sideways parabola, so we just need to show that that satisfies this ODE. I'm just wondering if I should try and simplify it. I guess it does simplify because these are like terms. Y equal to Wumbo? I haven't. That's a good idea though. I Wumbo, he Wumbo, she Wumbo. Wombology? The study of Wumbo? I guess we want plus or minus root x. And we want to show this ODE is satisfied. Technically, I guess we should also check the endpoints also. Oh, ha. I guess we only want the plus. Well, okay. Y of 1 equals 1 implies that y equals root x, just to be thorough. And y of 0 does equal 0, so that checks out. Now we plug it into the ODE. Root x squared. Okay, root x double prime is annoying. I can tell you that much. Uh, y prime 1 over 2 root x, y double prime minus 1/4 x to the 3 over 2? Yep, okay. So times minus 1 over 4x to the 3 over 2 plus 2 root x squared. Wait, no, I'm looking at the wrong thing. It's not squared. Now it's y prime squared. There we go. Hopefully this thing equals 0. Oh, this is not 0. Wait, yes it is. Okay, good. So we've done part A. Legendre condition is satisfied by y of x in 0, 1. The Legendre condition, you take two partial derivatives of this bad boy with respect to y prime. And you want it to be greater than or equal to 0. So that's two partial derivatives is just 2y squared. And that is indeed I guess we should I mean even just from that we can tell you that it's greater than or equal to 0, but let's plug in the actual extremal. Uh, 2x. Oh, actually, yeah, it is important to plug in the actual root x thing. Okay. Which is greater than or equal to 0 for x in 0, 1. Shows z of x equals x is not an extremal. And so we'd want to plug it into that ODE. And show that we don't get something that equals 0. Two x squared. Second derivative of x is 0. No concavity there. 2x times 1 squared equals 0. And 2x is not generally equal to 0. Okay, and then there's a typo in this problem. This is supposed to be greater than. So this J thing is referring to integrating. It is the perfect tempo for cat jam, yeah. Integral from 0 to 1 of the f function. So y squared, y prime squared. I think that's a piece of the Hamiltonian. It might be, at least. well, when we plug in the capital Y of x, which is square root of x, that's not, that should be 1. We get just x, and then y prime squared. We said y prime is 1 over 2 root x. Uh... 1 over 4, 0 to 1, dx. Dx's cancel, so 1/4. Whereas j of z, jz, yeah, and hopefully we get a number here that's bigger, because what we're doing is optimizing a path. I don't know exactly what this optimization would be physically. For whatever reason, square root of x is like the optimal path in this case. So z is just x, so x squared times 1 squared, so who cares about that? X cubed over 3 from 0 to 1 is equal to 1/3. And last I checked, 1/3 is bigger than 1/4. If you ask most Americans, they don't know that. Based off that thing between what McDonald's having the quarter pounder, Burger King tried to one-up them with a 1/3 pounder. But it didn't work because most Americans don't know that 1/3 is bigger than 1/4. The shortest path from a corner of a square to another corner. That should just be a straight line. Still. Because if I'm understanding what you're saying right, at least. Because if it's just like in regular Euclidean space, the straightest path, or the shortest path is always a square. Straight line. I don't... Oh, you can make it even stronger statement. For convex body, it's always a straight line. That makes sense. Like it's like on the surface of a sphere, it's still a straight line too. Reference to the perimeter of a square. Say you could travel across the surface. Any of maximizing the area for some reason. Uh, Sort of like you definitely need to have some sort of weird geometry. Oh, and also hi Baobab Tree. Sorry if it's been a while since you said that. Um, it would definitely need to be some kind of non-Euclidean geometries. It's like the perimeter of a square. I guess that would count. I'm not sure if root x would be the one that does that, but maybe. Yeah, I mean, like on the surface of a sphere, a straight line is a great circle arc. I mean, I just kind of those are the same thing in my mind, at least. Okay. Arc length formula? At least in Euclidean space, That's like the oh, welcome over to the Twitch side. Yeah, sorry, I just was paying more attention to like Twitch chat because it was like moving faster at the time, but that is a square root. Um, but this is no, no. I mean, I appreciate it because you're making me think about it. uh, why I'm racist? Hello, welcome in. You got a hell of a name. I didn't want to comment on Zach's stream, but like, of all the usernames you could have chosen, it's one of them. You're Martin. Oh, cool. Welcome over to the Twitch side, I guess. Assuming that. Oh wait, no, never mind. There's a Martin in the YouTube chat, but maybe you're probably different, Martin. Um, you are from YouTube. Okay, okay. So yeah, this is different because this is the thing that you plug into the Euler Lagrange equation. To that this is like the thing that we're trying to it's almost like a constraint that we're optimizing under. If you plug this into the Euler Lagrange equation, you'll get just the equation for a straight line, actually. Whereas the root x that we got from earlier is the result of the Euler Lagrange equation, not the thing that we're plugging into it. So it's like subject to a different constraint, which was like this. And I think constraint isn't the right word. It's more like a geometry or something, but I guess it's kind of called your index, and it's kind of a general thing. These are Euler Lagrange equations show the two definitions of geodesics are the same. I didn't know there were two definitions of a geodesic, to be honest. Would the Wikipedia article tell me them? Oh, this song's a throwback. Acceleration, free curve, locally minimizing distance. Oh. Huh. I didn't know the acceleration free curve one. No, no, no. It's not a bad association to draw because this is all about optimization. The stuff that we're doing here. It's just like the evolution of the maximizing area of fences thing. So that's not a bad thing to think of at all. Oh, I'm missing a 2. That'll be a glorious day, Winklebot. BRB, no worries. Okay, and then we need to do product rule on that bad boy. Minus 4y. Ooh, 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 ooh. Don't forget the y prime. 1 minus y prime. Wait, what am I doing? Derivative of this with respect to x. Yes. Mostly for minimizing functional problem rather than solving the OD or PD problem. Oh, really? Unfortunately, okay, I think this is a situation where we have to multiply all this crap out in group terms. I don't see a better way. Oh, that's not right. Minus 2y. I'm doing a lot of mental math here, and that's always dangerous. So I multiplied this out. I multiplied 2y into the result, and then I subtracted the entire thing over here. All at once. Let's see. Let's go over it a second time just to make sure I did it right. The cross term is minus 2y. Yep. I think I did it right. PD theory. Right. And even once you like get too far away from Laplace's equation, you lose the nice properties that you do have, right? It's just a rough world out there for PDEs. Okay, common terms. This, ooh, that's nice. Those two things cancel. These two things go together. Is my mouse getting moved or something? Zach, thank you so much for the raid. Welcome in, people. I hope the rest of your stream was good. Hi, raid. Hey, $5. Welcome in, people. Today I'm working on I'm starting off with calculus of variations homework, so we're just kind of doing the Euler-Lagrange equation a bunch of times here. That's what I'm working through right now. I do have some PDEs homework that I was trying for a little bit, but it's kind of difficult, so I put it back down. If I just kind of plow through this, though, I'll come back to it, though. There's big theory for the elliptic PD, just like Laplace equation. Outside of that, it's mostly custom argument for special cases. Okay, that makes sense. Yeah, my PD's professor is making like a point where like Laplace's equation is so like fundamental, which is an elliptic PD, because like so many other PDs look so much like it. Where like this is Laplace's equation, but then the heat equation is just the same thing but with a time derivative. The wave equation, same thing with two time derivatives, and then Schrodinger's equation, it just has, it's like the heat equation but just with an I in front. And so in some ways, like Laplace equation is still like fundamental to nature. Dojo, naming the Lagrangian F is cognitive dissonant nightmare? Do people do that? I want to say when I learned about it, we called it L. And hey, K-pars. I haven't seen anyone call it F. That would be terrible. So we have a just a fantastic ODE to solve here. What's even going on? Papadori, when your friends uses G, why? Um, I assume we don't care about a solution of y equals 0, so we can safely divide one of these y's out. We can also divide a 2 out. Welcome back, Winklebot. Ooh, this almost looks like a product rule, right? Or this looks like, it looks like something. What does it look like? Uh, it is Euler-Lagrange madness. And the question was to plug this thing into the Euler-Lagrange equation. Derivative of y prime. Let's see what that is. I have no clue. I was used to hate F and reserves L for fancy Laplace L. Ew. I don't agree with your friend. Almost product rule is almost the worst things that could happen. y prime prime. What does this come out to be? Y prime squared. Oh, collar cone. Yeah, you got it. This is a product rule. Nice. So this ODE is actually not that bad. Because now... Actually, I should keep that. Why would I delete that? Let's make it green, though. Hey, stop. What are you doing, Journal++? Okay. Now we integrate y prime prime respect to x. So trick, one of my former professors showed me that was similar to that. Yeah, the only reason I even thought of this is that one of my professors just casually used this trick last quarter to solve an ODE. I was like, oh, that's kind of neat. I know this is the same trick they use for integrating factors, just we didn't need an integrating factor this time. But I never think to like use it when I just see an ODE out in the wild. Except for now, I guess. All semester TAing for ODs finally pays off. So we get y prime is equal to 2x plus c. Well, c1. Is this a separable differential equation that's already separated? I guess it is. Integrate again. Hey, Vivin. Not Yzma. It's been a long time since I've seen that movie. Ooh, hyperbola? That feels significant. I wonder where this Lagrangian comes from. Oh wait, we're using F for the Lagrangian. I just didn't think about that. We haven't been calling them Lagrangians except in this prompt. I mean, we called them Lagrangians once or twice. We've just been calling it a general like function though. Significance of this function is purely hyperbolic. I think the class that taught me street fighting ODs for the Riemannian geometry, almost every ODE is nonlinear. Oh. Lagrangian. I remember seeing that course. What are boundary conditions? Y2 is 1. Y of 3 is root 3. I hope that comes out clean. Okay. Um, Folks know what they say about math puns, right? What do they say? Oh, so actually, my professor for the PDs class said that Lagrange. Wait, no, I'm sorry. This calculus variations class, he did mention Lagrange is actually Italian. He did mention he's like French by heritage, though. Math puns are the first sign of madness. I haven't seen that one before. It's a good one. Do you ever in math have C3P0, like C3PO? I feel like I've maybe had R2D2 or something like that. I don't know. This is just this is just vaguely reminding me of C3PO, I guess. Uh okay. What's happening here? 3 over 2 is equal to 9. 9. 3C1 plus C0. 15 over 2 plus 3C1 plus C0. Why did chicken cross the Mobius strip? To get to the same side. That's a really good one, Dojo. I like that. The Grange have a tattoo that was like Fabrica in Italy. Oh god. I would but believe it. Those shirts were kind of all the rage for a while. For Echo in Mexico. What's purple and commutes? What? An abelian grape? Oh god, that's a groaner right there. That's like the daddest math dad joke I might have heard. Ugh. I respect it though. Um, I hate fraction math. 16 9? 9 over 2? Oh, you heard the joke at the conference you went to? Nice. Okay, so we have, after the dust settles, a half y squared x squared minus 4x plus 9 over 2. This is the answer, but let's be overachievers and simple, like, let's make it look like a hyperbola. So we need to complete the square on this bad boy. We want plus 4. Was worth $1,000 on the undergraduate Jeopardy game, and you didn't know it. Oh, they had a Jeopardy game there. That's kind of sick, actually. Oh, is this like a scaled hyperbola, or like this is what do you call it when they don't have the same coefficient? It's almost like an ellipse mixed with hyperbola. Fraction math. Uh, that's plus a half. I want to graph this in Desmos. I don't think I know what this looks like. I bet it's just scaled a little bit differently than a normal hyperbola. Like it's gonna be a little warped. What was I writing? X minus 2 squared plus a half. Oop, that's not what I want. Minus a half y squared. Oh, that's kind of boring. Okay, that's hoping for something more exciting. Yeah, okay. You just have different slant asymptotes. Meh. An actuary will tell you the number of people that are expected to die each year. A Sicilian will tell you who. A Sicilian actuary will tell you who. Light mode? I know. I'm a light mode user. I'm sorry. You're lucky that I put my journal plus plus in dark mode. Ew. Mm-hmm. It's gross. Air Force One changes name depending on if you use president or vice president. I did not know that. So the real Air Force One was inside of us all along. Air Force Two is for the vice president. That makes sense. Can't disagree with that. Naming convention. Okay, I think this is my favorite form for this messed up hyperbola. Okay. Air Force, the actual plane name is C-32. That's much more boring. What about Air Force Route 2? That's when I'm on board. Is gamma of root 2 a special number? I feel like it's probably not, but it could be. I don't think so. What is G? The Barnes G function. Yeah, I don't know. Oh well. Okay, did we answer number 4? I think we did. Number 5. Grab that. Okay, I was trying this one a little bit off stream. And I kept getting confused on why. The problem is kind of a cool application though. So of like calculus of variations. We need to practice squeeze theorem for sequences still. Struggling hard doing yeah, squeeze theorem is a tricky one. It requires you to like be creative, and those are always the harder theorems to use. So yeah, so this is a question about flight path. Basically, if this is the surface of the Earth here, you're starting at this point here. Actually, let me just put it at the very end. Starting at this point, ending at that point, it's a distance d. This is the shortest path like along the ground. The question is, what's the optimal altitude to fly at above this path? It's definitely like this. Include a loop-de-loo, I think. No. Like what's the optimal like altitude to fly at? The trade-off is the higher up you go, the less air resistance there is, so you use less fuel. The bad part is the higher up you are, the longer the arc length is. Like, this is a shorter distance than this, is the trade-off. And so the function that we're trying to make is I think I've been overthinking this, but I think basically x is like it's just gonna be the distance along this path. But I get confused because like it scales differently depending on the height. But I think I just need to ignore that. The distance above the ground at any point is y. We need to approximate. I already read that. We're flying east, west, or north, south. We're ignoring that. I think we're assuming that the Earth doesn't turn for this question, or we've already accounted for that in the path itself. Boo. I mean, that's how math works. You start with a simple problem, and then you make it harder. Don't bring Feynman diagrams into this. The plane takes all possible paths, and some of them interfere with others. It's true. Oh, I'm sorry, Winklebot. Let's include the east, west, and north, south question. Let's also throw in wind direction in there too. And no, simple is a relative term. I mean simpler than like what the question could have been. In French, the squeeze theorem is sometimes called the theorem de gendarme, which translates to the police. Yeah, I've heard that. The policeman theorem is like the drunkard's theorem. That one has a couple of fun names. And so we were given kind of the thing to optimize in class, sort of. It's the integral from a to b. E to the minus y over h represents the savings in fuel when you fly higher up. And you multiply that with the arc length of the path. And so this represents the total like cost of fuel, I think, or something correlated with the cost of fuel. And so that's why this represents the trade-off of kind of the higher up you go, the bigger the arc length is, but also the smaller the cost of fuel is. A mathematical definition of simple is a function of confidence over time. Oh yeah, okay, that took me a second to figure out, but yeah. After putting the squeeze on the crooks, yeah, exactly. Because you have some. Oh, thank you, Fembox. Say like this is the sequence or function that you're trying to bound. It's like some crazy like drunkard that's going every which way, and then the policemen are the orderly ones that are like doing a good job of bounding the drunk person in. That's the idea behind that like name for it, I think. And so I think we also need to define our endpoints. So y of 0, we start at height 0, and I'm hoping we just keep it as simple as y of d equals 0, because we definitely end at height 0 also. The thing I'm worried about is like, is the input actually d here? I think it is, and I just shouldn't worry about it too much, but I feel like it's almost not. You have to remember that? Yeah, it's fun. So the integral's from 0 to d. And so this bad boy is our f, which I didn't realize we were using f to stand for Lagrangian. But we are Lagrangian. So we're going to plug that f into the Euler Lagrange d. So d by dx, derivative of that with respect to y prime, e to the minus y over h stays the same. Y prime over root 1 plus y prime squared. That, oh, come on. I don't want to take the derivative of this with respect to x. Are you... Really? This sucks. When do you think we start using Klingon letters as constants? I mean, hopefully sooner rather than later. Yeah, I'm gonna do it. I just want to complain about it first because that makes me feel better. And thanks for the follow, Bistolus. I have had the thought that we should switch to using like Mandarin characters or Japanese characters or something, because there's like thousands of those. And we've really just been recycling English and Greek letters for a long time. Or as Zach says, Ninja of X. There's no shortage of emojis either. Okay. Let's stretch out before we do this giant quotient rule. You know what? Let me get some water too. Some water too. Turd of X? That'd be a really funny way to turn in a homework assignment using turd of X as a name of a function, as a way to like throw shade at the homework. Okay. It's a quotient rule and a product rule. Kappa of smiley face. It's low D high minus high D low. Low. D high. Ugh. Ooh. I'm gonna mess this up because it's d by dx total derivative. I'm gonna forget it. I'm gonna mess up the chain rule at some point. Mark my words. Ooh, so we have a y prime from chain rule. We have a y prime from that. I already like this song. It's only 5 seconds into it. Let me add it to my playlist. Okay. Okay, so that's the first part of the product rule. Now we take the derivative of that piece. So that's easier. Okay, so that's low d high minus high d low. Ugh. Wait. You guys waiting? I don't think you're waiting. It's 2y prime y double prime. Because total derivative in x of that. Wait. No. Ugh. Hey, Art. I was doing it with the negative exponent. I need to make it positive. D by D vomit, some bullshit equals nightmare. True. Y prime, Y double prime. The 2 in front is going to cancel with the 2 that we get from the power rule. I think that's correct for the numerator, the quotient rule. Sounds good. Winklebot, hope the work goes well. Thank you for hanging out. Okay, now let's just solve this ODE, guys. It'll be a breeze. Yeah, just plug this into the plane, and you're gonna save tons of fuel. I guess the first thing I want to deal with is this common factor that's kind of dotted throughout. Linear algebra is annoying. I don't know about that. It is a job for Mathematica, to be honest. I even typing this into Mathematica is kind of a task, though. It's a job to take a screenshot and give it to AI and get a wrong answer. The exponentials, I think we can safely cancel those. I sure hope so. Gotta solve 100 integrals? Oh, disagree, Art. I mean, if the algebra class is being a real pain, though, I could kind of see that. But linear algebra is good to know, I think. I'm gonna cancel the exponentials. Sue me if I'm wrong. Let's just start hacking away at this. Uh, that's not right. What am I doing? Kind of his own notation, kind of hard to on the topic. That will make it a lot more difficult. What do we get from this? Let's divide out the root 1 plus y prime squared. Or do we multiply it? I think we multiply it. We want to get rid of the denominators. Okay. Let's keep track of what I'm doing in this step. Okay. This is gradually getting less disgusting. Like me. You know, that's... Ugh. Um... I guess we just need to multiply this out. There's not much else to do here. Y double prime, y prime squared. Y prime squared over h. Wow, we get a y prime to the 4th? Look at you. I hope we get some common terms here. Oh. Oh. We're getting a cancellation for that y prime to the 4th. Hallelujah. Okay. How does this thing clean up? That cancels with that. Do we have any lone y double primes floating? No. Do we have anything like that floating? Y double prime. Ooh. That goes off with that. Oh, dude, this is cleaning up. Okay, those don't quite cancel, but becomes a plus y prime squared. Right? This is a Riccati equation, isn't it? If I do reduction of order. I think that's a Riccati equation. Am I street fighting? I sure am. Riccati spotted. If Q0 is 0, no, it's not 0. How, where, what were we doing with these before? I think in my class with these, we were doing asymptotics. So that's not really helpful for what we're trying to do in this problem. Are these constant coefficients? That's nice. Wherever Q2 is non-zero and differentiable. What is my Q2? The coefficient of... Okay, minus is a constant 1 over h. Is there a simpler way? Like, I have constant coefficients here. Is it separable? Oh, yeah, this baby is separable. Who needs Riccati? Yeah, this is much easier than Riccati. They really don't color cone. Riccati is not it. I believe that's arctan. My lasagna needs ricotta and mozzarella. I was trying to think of a ricotta joke. It wasn't coming to me, but you found it, Dojo. Congratulations. Oh. Oh, no, I think we'll be okay. Yeah, it checks out, Dojo. Okie dokie. Hello there. Oh, is that for oh I didn't know that they made a badge for Artemis too. That's cool. I was worried about integrating this, but that's not a difficult integral. And an emote. Oh wow. Can anyone use that or do you have to unlock it? NASA Sparkle. Let me see. NASA. No, you have to unlock it. I wonder if it's too late. So why is what tangent is it ln secant? What's a derivative of ln secant? Aha! I got it. It comes with a badge. Okay, I'll have to see how you unlock it. 24 days? Okay, cool, cool, cool. I'm glad it's not too late. Why did the ricotta roller skate? Because it wanted to feel way cool? Wait, isn't whey like a protein thing? Or like from wheat or something? Oh wait, no, cheese, or I don't remember. I don't get it. Ricotta roller skate. I don't know. Hey Viv, it's been a minute. Thank you, thank you. How have you been, Viv? You can make ricotta from whey. Oh, I didn't know that. Okay. Dang, that's a deep cut then. And okie dokie, yeah, of course. Do you know the way? I watched the launch afterward. Yeah, I'm realizing that I don't quite know what whey is, I guess. I was associating with the wheat in my head, but maybe it's a cheese thing. Wow, there's an honest to goodness ricotta section on punpress.com. Oh, they would make sure to stay up to date with the times. Why did the ricotta go to therapy? It needed to work out some way. Oh, that's terrible. Oh. What do you call a cheese that's not yours? Nacho work. Oh my. These are. Oh, ew. No. Oh, terrible. Oh my god. This is ChatGPT or something. I'm sorry. This is Sarah Blake. Yeah, sure. Sarah Blake GPT. I guess it makes sense. So if whey is leftover from making cheese, like I feel like humans have been looking for uses of leftovers for like as long as we've been around. So I guess it's a way to it was a way to use up like discard. That's cool though. Making my own cheese would be like really fun, I feel like. Okay. Okie dokie says, asking for a friend. If they have a 62% in the class, do you think they should take the W instead of the F? They also have an exam in the next few days. That's a really tough question. Uh, so like, it's the upside of taking a W that you avoid having the ugly F on your transcript, I guess. It's its semesters, so maybe like, are they about halfway through the semester? I guess it's a matter of like how optimistic they are about the rest of the class. Two cheese are walking through the woods when they hear a spooky sound. One cheese turns the other and shouts, "Ricotta Gouda here? Oh my god, Viv." That is terrible. Maybe listen bad jokes today, became a dad. I do remember you have dad jokes for days, Viv. I redeem a backflip. When I was a kid, I actually I don't think I could do a backflip just like on flat ground, but like on trampolines and stuff, I could do backflips. The answer is no. You can't. 3/4 through. We don't usually count for or W's don't usually count for GPA. Okay. Uh in that case, it's assuming they don't see themselves coming back in the class, it probably is better to take the W. It is kind of a crappy situation, though. I don't know. It's kind of a matter of like whether they want to bet on themselves to make a comeback, I guess. Wait, a drawing of me drawing myself doing a backflip while eating ricotta. This is a complicated picture. Okay, let me just do this integration and then I'll do that drawing of a drawing. If I'm integrating, I'm multiplying by negative h. And then we'll have to figure out C1 and C0. Oh, okay. Oh, you prefer it that way. Okay. We can do whichever way you want. um I always forget what shade of white I like to use. I think that'll do. The only downside I feel matters of W's have to retake the class and pay tuition. Uh, I mean, yeah, if they get an F, I assume they would have to retake it anyway, or at least potentially a different class instead. I guess it does depend on their like program requirements too. Where like even a D might not be enough. If it's like a core class, they sometimes require you to get a good enough grade in that core class, like not just passing. I don't know how common that is, but it's a gen ed. Okay, so probably not that strict. Somehow D passes. Okay. I'm kind of curious to see what this thread says. So I've never been in a situation where I've had to potentially take a W. D equals to diploma? Sometimes, yeah. How much does like taking a class cost in the US? It varies a lot by the institution. You're for like a 4-year university, even like a public university, which tends to be cheaper, it's still a few $1,000s per class, usually, like 2 to 4,000, if I were to put a number on it. That was my friend's memo. W doesn't impact GPA, can be attributed to anything, has been normalized by COVID times, you're good. It's not a bad attitude. Like if they go on to like apply to grad school or something, it'd be something to probably explain on their personal statement. I guess the upside of the situation is that if they're just trying to get their degree and not do anything else after that, it's not a big difference, I would imagine. Like the W is probably better for the GPA reason, but like employers aren't going to care that much about whether they have a W or an F. They probably aren't going to care at all in a certain class, so especially if it's a gen ed. Ooh, that is a thing to consider. Financial aid in being enrolled in a certain number of classes. That's a big consideration too. Something to ask the financial aid office about, probably, because it probably depends on the school. But you talked about tuition. Fair. Oh yeah, you do potentially get a tuition refund. Uh, Depending on what, like, how far into the semester you withdraw. Usually it's like by halfway through, it's you're getting at best half your tuition back, probably less. Can you explain to me how, so I can tell a friend how probability is helpful in the real world? Dojo, you're saying it rarely is? I think probability is like one of the few things in math that is pretty applicable to the real world, or like directly, like easy to see how applicable it is. Welcome back, Martin. I'm just gonna call you Martin because I don't want to call you racist. Helps you avoid playing certain games of chance. Is also playing Monopoly and Catan? Yeah. So Martin, there's a few things that we're talking about right now. So Okido was asking about advice for a friend about either withdrawing from a class or just failing it, which is better. And there's a lot of considerations as it turns out. And then Okidoki and asking about how probability is helpful in the real world, which I'm still trying to think through my perspective of it. Hard luck. I failed a class once. It was a class on jumping out of airplanes. Luckily, I bounced back. That is lucky. So yeah, probability is helpful for like pretty much every game, or almost at every game at least, and making better decisions in those games. Same with betting. If you're willing to extend the definition of probability to include statistics as well, statistics is really like important. Like any like academic paper you read, or a lot of academic papers you can read that involve an experiment are going to have a p-value, and knowing what a p-value is, it is a probability, and it's important in a certain like context, and that's, I think, good to know. I wouldn't say like you need to know it in the sense you don't need to know very much in general to live a happy life in theory, but it can improve your life and make it better. Financial decisions should not be using pure probability. Using expectation will lead to terrible outcomes. So yeah, I assume that's about like betting. I mean, you should be informed by it, Dojo. But like, yes, it's certainly like, just because the expected value of something is positive doesn't mean you should sink your life savings into it, for sure. Jed, I failed orchestra one semester in college. I was absent the day music was given out. I lived off campus and I asked for the music every week for the rest of the semester, but never received it. I didn't show up for the concert because I never got a chance to practice, so the professor failed me. Then he went to Europe for 2 years, so I had no way to communicate with him. What the hell? What a crappy professor. That sucks. At least I can build a wall. The questions like P of A given B and stuff. Yeah, I mean, that's the exact thing. Like, if you're playing like poker or something, you can ask like, what is the probability of, like if it's like Texas Hold'em, what's the probability that the next card they put out in the middle of the table will be like a hearts, given there's no hearts currently out on the table. My notation here is terrible, but well, this is just like a specific example, but like conditional probability is really important, and like it's like you can express that. I'm just saying this is like the language you use to talk about probability in games in general. Like the fact that I'm just talking about poker in particular is irrelevant. Conditional probabilities happen in pretty much every interesting game. Sub 3.8 GPA that semester because that F you didn't make the dean's list. What a jerk, that guy. Where's the red button to press? So yeah, oh yeah, that's a really good one, color cone. Um, yeah, for like blood tests or like, any test is like, I guess like positive and negative. What's the probability that you have a false positive or a false negative, like type 1 and type 2 error? So yeah, I like the problem with this line of questioning is that you can always like keep drilling down and say I don't need this, I don't need that, but I think it's just the wrong attitude. Like and people do it a lot of times out of like frustration with like taking a class. It's not completely unfair, but like I don't know, I think people are just being obtuse because they don't like something means that they don't see the use in it. Or like they kind of like blind themselves to the use for things, I guess. Like I don't know. I'm not doing a very good job of expressing my thoughts right now, but like humans spend a lot of even humans who don't like math spend a lot of time thinking about probability, and being able to actually write out probabilities in a formal mathematical way can be helpful. I don't know your friend's life, so I don't know like exactly what part they may or may not be interested in, and they might not be interested in any part of it, and that will be fair. But like I can't I can't answer everything for them, I don't think. Friends in graphic design. Um yeah, I mean that doesn't have a lot of probability in it, but like if they really feel this way, hopefully there's a different gen ed class that can fulfill that requirement. Like I don't know, I'm not making them take anything. The ultimate answer is 42. It is. Probability of making your flush or making your straight can help you with odds and whether bet size is appropriate. There's another level of the range of hands your opponent might have, as well as whether your bet after the made hand will pay off. Right. Part of the issue is that the question, when will I use concept as a trap? It's hard to predict. Any particular person will use concept. Yeah. And even then, I have a problem with just the premise of the question, which is like, I feel like if someone's going to ask that question about math, I think they should also be asking that question about reading a Shakespeare book or memorizing the periodic table of elements or anything else that they might learn in school that I feel like doesn't get questioned as harshly as math does. Probability of Don Factorial drawing himself doing a backflip while eating ricotta is high. It is. Interested but stressed due to the professor. That's fair. I mean, it sounds like either taking a different class or taking a class with a different professor might be the answer for this person. So hopefully like a good professor can like inspire students to become interested. By default, humans are terrible to have intuition on conditional probability. There's a drug prescribed a while ago that were actually the worst for patients that not taking it. Doctors thought, based by experience, that this was helping. Interesting. Yeah, that's fair. Okie dokie. Um, I don't know. I'm sorry for your friend's situation. It is tough. It sounds like the professor isn't that. At least the professor's style doesn't fit with your friend's learning style, to put it kindly. Your name's atomic number 93. Take that. 92. You know what, Zach? I'll just pretend I didn't see the first part. You got me. How many of them can I name in order? Oh, well, oh, good. I'm writing white text on a white background. Hydrogen, helium. Oh shit, what's 3? Is it lithium? I'm already lost. 4. I should know. It is? Okay. It's not carbon. Is it carbon's like 16, isn't it? No, I already don't know. I thought I would do better than that. I can name a bunch of random elements, but in order, I'm already tapped out. Um, Professor goes really fast. Yeah, there's that's way too common a thing for math professors to do, of just speeding through the material, and a lot of math is taught terribly in my opinion. And that's part of what brings like a lot of us here to Twitch, which is just wanting a different way of learning math. Uh I have too many tabs open. Let me clean these up. Oh, this is like a pretty clean website. The FBI technically censor part of a text. Oh, where they just like yeah, uh white text on a white background. It's a way of censoring. It's oh, is your friend actually like watching? That would explain a lot. um uh I would say I consider science separate from math, but math is like the language we use to talk about science. Um or like science relies on math for its language for the most part. What are they gonna do for the later ones? How long is this? 3 minutes? Okay, I want to hear the whole thing. Not this version. I've heard similar. You're at least 10 million of those 60 million views. Okay, we're getting into the funky ones soon. I wonder what they do like after uranium. Oh, it's just what they're named after now. I didn't know Tennessee had one. Huh. They forgot copium. uh. Yeah, Colicon, that's what I was interested in. There's not much that they can do besides just talking about the names, I guess. Most important one's a human. Quite, oh, we're really hard luck. Yeah, so I've heard like in Breaking Bad and Better Call Saul, there's that character Gale who's like the mega chemistry nerd. And definitely he might have done in Breaking Bad too, but in Better Call Saul, he's basically singing that song or a version of that song, and that's where I've heard it. Okay, me drawing myself doing a backflip while eating ricotta. Now, I guess technically the phrasing of this does leave it open to interpretation. I could be eating ricotta in the drawing while doing a backflip, or I could be drawing while eating ricotta. We have options in life. Um, how am I gonna see a Martin? 3 a.m. already? Geez, yeah, you should go to sleep. So be like an angled table where I'm drawing, I guess. On 5, like April 5th? Or at 5. Or if you just want to go to bed, then go to bed. I could land in the ricotta. I think that's much more fun. We should do that. It's gonna annoy me if these don't line up. Stop. Behave. No. Line up. Line no. Bad. No, actually that's not what I want. Why? Why do you torture me like this? Okay, fine. That's the best we're gonna do. Okay, I need a bigger. I need to make that bigger. That's what she said. We need some high resolution on this drawing. This is the paper. Okay. I think okay, so if I'm gonna land in the ricotta, I'm picturing like a diving board type of situation and a pool of ricotta. ricotta. I guess it's gonna be some gray ricotta because just white wouldn't show up very well. So ricotta's gone a little bad. The bold guy that whispered to PNG. I don't think I know that. Okay, how do we draw a backflip now? I feel like I should be mid backflip. Like this should be an action drawing. So I should be like curled up into a ball. I'm gonna be wearing green pants because that just feels right. Wait, okay. I should be in a ball but upside down. It is Dojo Drummer. I hope we at least sort of address the probability thing. I could have. There's a better answer out there than what I said, but I'm not sure what more to say right now. At least. So wait, okay. If I am doing a backflip, I'm on the diving board facing that way, and then I tumble around. So if I'm in the middle of a backflip, my head is right here. I'm looking that way. Wait, am I? No, God damn it. A backflip is hard to visualize, as it turns out. Okay. I start facing that way. If I do a backflip, the way I'm facing is normal to this curve. Outward normal. Now we can find the flux through the surface. I think I had it right. Kind of a straight face. I'm very serious about this. I should draw my legs first, maybe. I'm wearing green pants because I feel like it. This is gonna look terrible. I should do one? I can't do one. I'm gonna hurt myself if I try. Light blue shoes. Because I know what fashion is. Do some squiggles in there to represent my hands. Give himself some hair. Need a beard. When you do a backflip, you like curl up into a ball in the air and then you come back out. That's what I'm trying to be in the middle of a backflip. Maybe we need some action lines. Yeah, a tuck, exactly. So like he's gonna keep, it's me. I'm gonna keep like spinning, like I've done half a spin around. I'm halfway through my backflip, and then I'm doing another spin to land on my feet, or half spin. Clearly. You know, I thought that was obvious from my incredible drawing skills. Short little legs, you're great at cranking out pike flips? Ooh, I need to look up what a pike flip is. Air momentum is more important than probability when doing pike flips? True. Oh, that's just a backflip. What the hell? Oh, I guess a pike flip, you don't tuck your legs in? Straight leg, okay. I guess, is that maybe... Is that easier or harder? I'm trying to think of the physics. I've never been good with angular stuff, though. It's probably easier? Because your legs being straight helps you rotate faster, maybe? I might have that backwards. Okay, this part of the drawing already took so much effort. I'm gonna phone it in on drawing myself. You think it's harder? I would believe it. I don't know angular momentum. That's my problem. It's always been the hardest part of mechanics. If my chair spun better, I would try to do that in my chair right now. You speed up with the arms in. Oh, really? Okay. Think of a figure skater? Oh, yeah, okay, that's a good thing to think about. There we go. Looking good. Needs some hair, and I think we got ourselves a drawing. That looks... My beard looks terrible. Oh, I forgot the mustache. Okay. No hair? Okay, fine. You like it like that? Turn that front upside down, literally. Ricotta is bad. Yeah, I would definitely not eat gray ricotta. Okay, well, I feel like you're calling me bald right now, but oh well. Okay, I'm gonna call this a drawing and get back to the math, unless uh you have anything else to add here. Oh, Plasma posted a cat pic? Hell yeah. Kind of a weird angle for a cat pic. I'll still take it. Hey, Muhammad. Okay. Posting this in the Discord because everyone needs to see my perfect art. I'm going to cash in that redeem. Okay. Thank you for the redeem. Okay, so we're still in that flight path problem. I think we're through with the hard part. We need to bring in our boundary conditions. Hopefully we get something that's valid. Ooh. Secant? Where are the discontinuities for secant? Secant is one over cosine. Cosine is 0 multiples of pi over 2. Yeah. Odd multiples of 3 pi over 2 at least. Hmm. You have a domain issue. That's annoying. I don't know, let's just blindly plug this in and see what happens. Y of 0 is minus h. Ooh, this could get disgusting. I guess we subtract the two equations? I'm not a fan of this, though. Scrapped it on Desmos. Makes sense given the cost function. You take off almost vertically. Oh, wait. That might be serious. Actually, no, I'm sorry, Dojo. I thought you were making a joke, but I just realized that does make sense, actually, if you would take off almost vertically. Um, oh. So we do have a slight issue. Well, do we? No, we don't. So the h's can cancel. We do e to the power of each side. We get secant minus d over h plus c1 over secant c1 minus ln secant. Right. That makes sense because secant close to 0 on the right. Oh no, secant of 0 is 1. I don't know. Never mind. I'll plug in Desmos for myself in a minute here. Oh no. I'm gonna get garbage out of this equation. Crap. No subscript. Is there a minus in front also? Oh, there is a minus in front also. I don't know if that's a realistic function or not. Um, I might need to check my work on this ODE. I don't want to. I don't know. I've lost my steam with this problem now. There is a sixth problem we could look at on this homework. I think we'll pivot to that because I don't know what to do with this problem right now. Because there's a second issue, which is even if I could get C1, there's still no way to determine C0 with my equations. So I don't know. Because I don't think there is. I guess no. I guess I could. Never mind. Um, well, let's think about 6. So I don't feel like thinking about 5 anymore. So we need to derive the Jacobi accessory equation p of x h prime prime minus q of x h equals 0 for the definitions of p and q. So the Euler d for the accessory. So we talked about this in class. And what this is talking about is something. Not nothing. Trying to find in my notes. I don't know if that's another theory of why we care about this. But I believe we take small y of x equal to big Y of x plus epsilon h of x. And so y of x is the true minimizer. It's like the shortest path. And so small y is some small deviation from that path. And h of x has some conditions on it to be sure that y of x is also a valid path. What the Jacobi accessory equation talks about is basically the h of x that satisfies the Euler differential equation, which we call capital H. And that's important for checking that your minimum path is, or that checking that your optimal path is a minimum and not a maximum, or like the equivalent of saddle point or something. But I'm not entirely clear on like why we're doing this Jacobi accessory equation, but I think we can do it without understanding it. So I think what they want us to do is start with the Euler differential equation. Which I'm going to write slightly different notation that I've been writing earlier. So these subscripts denote partial derivatives with respect to that variable, y or y prime. The hat indicates that we're letting f hat of x is equal to capital F of x, capital Y of x, capital Y prime x. It just means like you're it's the Lagrangian with the optimal function plugged in. But I guess hat here is going to be small y, ironically. And we're reusing small y to mean two different things, both a variable and a specific thing, because we just, you know, this is just great notation. Uh, So I assume we're taking, I guess let's just start cracking. D dy prime of this. Well, how does that make sense? Isn't that 0? I think I'm already doing something wrong here. uh, that's weird. I'm I'm trying to figure out what, like, I'm worried this f hat is different from this f hat. I feel like the thing I need to plug into the Euler differential equation is a little bit different. Look in my notebook right now. Yeah. Okay. I am plugging the wrong thing into this. I think we're naming a function g of x h h prime. Where does this come from? Oh. Huh. Okay, so let me back up a bit. For the Jacobi accessory problem, looking at a small j of h. I'm not sure. Hmm. Okay, well, let me back up even further than that. If we want to be assured that our capital Y function is a minimum, we want to require the second derivative of j with respect to epsilon. Evaluate epsilon equals 0 is positive. Thank you, Fembox. And J of Y is A to B f of x, y, y prime, dx. The thing we're interested in for this problem, I think, is J of capital Y plus epsilon h. Which we're calling a function to epsilon, maybe? Doing cryptic crossword? Ooh. It's a fun activity to do with your mom. How's a cryptic crossword different? I'm going to look it up. Hare no longer laughing, with tortoise halfway to a comeback. Oh. It's just a riddle, isn't it? I guess you could have an entire crossword like this, though. It's just a... I guess it's minutecryptic.com, this website. Yeah, okay. So I can imagine an entire crossword with just clues like that. That does sound like a challenge. Crosswords are already, like, they're kind of difficult to get into because I feel like they have their own, like, language you have to learn with uh what clues kind of lead to what. Oh, I just saw Hardlock post something in Discord. 3 log y. I don't know what that is. Did my computer just freeze? Okay, never mind. It didn't. Um, oh my god, the professor for this class was doing some super weird notation. Um, actually, okay, no, before I get into that really weird notation, I want to write out, I want to complete this integral. I guess. Join the jams while I lurk and work on a paper. Oh, nice. Thank you for the lurk and for enjoying the jams. Okay, so actually this is good that I'm looking at this part of my notes. So if we take the derivative of this with respect to epsilon, in one version of the of the notes, the rotes, I'm turning into Scooby Doo. Ruh-roh. I guess I'm using capital H now. We wrote that. The next day, Where is it? Okay, the next day. I'm gonna write exactly F sub comma Y, as in a comma subscript that he didn't explain what that meant. Plus F sub comma Y prime, all in the subscript. H prime. So I looked in the textbook, which he wrote, and the comma is meant to just denote a partial derivative with respect to that variable, I think. But just write the frickin' subscript. Like, what? Why do whoever uses a comma there? I've never seen that in my life. But yeah, these two things are supposed to be the exact same. So, the comma is just so weird to me. If you sow your wild oats, hope for a crop failure. Okay. Anyway, tell me not to have sex with strangers. Oh, probably. And yeah, it's the comma for partial. Have you seen that before, Color Cone? You have? Okay. Maybe it's not my professor being weird then. I thought we people just used the subscript and didn't put a comma there. Fij? Why not just Fij without the comma? That's what I'm used to. If you sow your wild oats, be sure to put a rubber over them, plasma, if nothing else. Would be mean I indices taking the J partial. Oh, okay. I mean, that makes better sense. Can you buy me a PS5 Pro? Only if you're a good boy all year, Dr. Cook. Maybe Santa will bring you one. How much is a PS5 Pro? My oats are soggy. Oh no. PS5 Pro. The prices are going to go up this week, apparently. Oh, it's a cool 750 bucks. From Walmart or Target. You can pay an extra $100 if you feel like getting it from Best Buy. An extra 150 if you go to GameStop, apparently. Maybe they include different things. What console is possibly worth that much money? Like, what does this thing do? Differential geometry, you have geometric tensor Gij. Oh, alright, color cone, I guess. I don't like it. That you're giving me PTSD actually from trying to learn general relativity and all the Einstein notation and stuff. You want a PS5 Pro too, Fembucks? I want one just so I can play Bloodborne and Demon Souls. No other reason. That's ridiculous, though. I mean, those games aren't for everyone, Dr. Cook, but I really love them. I love like the dark kind of like horror, but it's also like just really like um I guess like challenging, but in a way where you can really see yourself progressing and learning. It's not just beating you over the head. Not usually, at least. I'm surprised that consoles like are still even a thing. I feel like PC gaming has just gotten like way more popular in the last like 10 years. I would like to understand, so the derivative of j with respect to epsilon. If we take the derivative with respect to epsilon, how do we get this again? I figured it out during lecture eventually, but now I don't. I've forgotten again. I have dedicated console in front of my TV, Super Nintendo and N64. I mean, those were cool consoles to have, though. Yeah. Growing up, I had a Nintendo console. I had a GameCube and then a Wii. I had a few handhelds. I never had an Xbox or a PlayStation though. I had an Xbox as an adult, but by that time my friends had already switched to gaming, or they like switched over shortly after, so I didn't get like that much use out of it. Color cone. This is just a generic function. Like there are terms at the top of the screen. I'm trying to derive an equation. We don't have a specific function. Does it not have an... I thought that like the Switch 1 switched to OLED at some point. Did they go back for Switch 2? It's kind of crappy if they did. Yes? Wow. Rest in pepperonis. Um... int AB. Oh, yeah, that's like the thing we're trying to optimize. Capital Y specifically is like the minimizer. It's the actual extremal. Small y is the variable. Integrate under the change integral. Apply the chain. Yeah, so I know that the derivative can come inside the integral. I know it comes from the chain rule. It's just not making sense to me right now. Or it's like just for everything, this isn't making sense to me now. Or like, it's the chain rule part specifically that's not making sense. Um, should go back to where we originally did this in my notes. Taking derivative with respect to epsilon. Where does the partial in terms of y and y prime come from? I can understand having the h and the h prime outside. But the partial in terms of y and y prime, I don't know. df dx dx d epsilon plus df dy. Right. And so the first term is 0. But then the df dy... Or no. Yes. Or I'm saying, I guess the dy d epsilon, isn't that also 0? Oh, wait. I'm getting mixed up with capital Y and lowercase y, maybe. I sure am. Oh my god. Yep. Okay. I see it now. uh, yep. Okay, because small y is a function of epsilon. I was thinking of big Y, and that's not a function of epsilon. Okay. Thank you, color cone. Music stopped. Okay. Now we want the second derivative. I've kind of lost the plot of why I started doing this, but this is studying, if nothing else. I mean, this is the small j of small h that is going to be related to the actual problem, I think. So actually, this rotation is going to get more convenient to use the other thing. F sub y h f sub y prime h prime dx. So we're taking another derivative with respect to epsilon. So this I'm taking another derivative of that and y. We get an fyy squared. And then we get a mixed partial. Doesn't give you necessary condition for y to be extremal, the first derivative test. Right. Yeah, that's what the problem is like. I'm basically trying to... I'm doing this just to figure out what to plug into the Euler differential equation. It won't be this f. But I think once I do that, I'm supposed to end up with this Jacobi accessory equation that tells you about the convexity, as you say. Then derivative of that one, get a y prime, h prime squared probably. Yep. We get another mixed partial, which we're going to assume these are continuous, and so the order doesn't matter. It's like, whose line is it? Anyway, the points are made up, or no, the questions are made up and the points don't matter. Is there a question that is not made up, though, to be honest? Like, I think all questions are made up. Nope. Okay. And so this bad boy is our G. X H H prime. I think you are color cone. Hey, Skirtle. You don't gotta put on the purple light. So my I was trying to figure out how to do that Skirtle, and I couldn't. It is possible for my lights to like do little shows, but I don't know how to do it through the API. Want to do when I get killed in games? Oh, I'd have to. Yeah, like what would be a good light show to do for that? There's like a DIY thing where you can make your own little things. I just don't. I can't figure out how to control them like with a chat command. So like I can make it. They're just not very they look really customizable and then they're not. That's it. Okay, so like let me delete these other colors. Speed. It's hard to tell, but it's flashing between red and purple right now. It's not that fast. I wish it was faster. What does crossing look like? I don't know. It's a lot easier to tell when I'm streaming at night too. But yeah, so it can do fancy things, but I haven't worked out how to do them in chat commands. Fundamental limit of calculus of variations? Maybe. Um, I think we were saying in class to just plug this thing into the Euler differential equation. I I, I'm gonna keep trying to figure it out, Skirtle, but the API it is really weird, and the documentation is only kind of helpful. You believe in the goodness of mankind? Yeah, I was about to say that's a complete lie. Uh, int f phi equals 0 for all phi with compact support implies f equals 0. Okay. Did we learn that? I don't know. Oh, that I think that's where it comes from. Yeah, I'm probably gonna skip that step, but that is where the differential equation comes from. Yes, we do have that fundamental lemma, and that's where the differential equation actually comes from. Okay. Also, like, what is a lemma? I always thought lemma was kind of like a side thing that's not too important. But that seems like a really important thing. And I feel like I've seen a few other things that are called lemmas that like seem kind of important. It is a minor thing. You just prove a larger statement. Yeah. Yeah. Okay. I guess that's why maybe it's a historical thing. You start out thinking they're a lemma, and then they turn out to be more useful than you thought. I like Jordan's lemma too is a big one. Yeah, like um oh, I guess so, yeah. For Wyatt's lemma. That's fair. Okay, what is d by dx of g sub h prime? Derivative of that partial with respect to h. H prime. Then partial with respect to h. Okay. For weak solution to PDE and distribution theory, this lemma is very important. Ooh, I could see that, yeah. Okay, now we need to take the derivative of this with respect to... Do we want to do that? P of x... Oh, these are supposed to be hats, by the way. Probably. I don't know. It's how it makes sense of derivative stuff that aren't differentiable. Oh, okay. P of x is f y prime y prime. So I guess the 2 cancels out completely. We can do that. Okay, so this is this, if we include that. So we I guess we're going to do a product rule on this potentially? Yeah, we probably do. Okay. I think I see the way forward. H prime f y prime h prime prime equals. You have to prove Euler theorem for homogeneous distribution tomorrow. Godspeed. I'm nervous about how my PD's class is gonna go. It doesn't seem like it's gonna. I was hoping it'd be a little less theoretical than it has been these first 2 days. You're so helpful, Skirtle. Okay, and so these 2 bad boys cancel. And I think we just have what we want, hopefully. That doesn't sound fun to me either. I don't quite know what it is. Also, though, to be fair. The PD course, where can I bring up the course description? 1 second. Okay, it's right here. Oh, well, that's a little general. Uh, I don't think he's been very specific, to be honest. So far, we've just been talking about properties of like the Laplace equation and like the mean value theorem, whatever it's called. Uh, the professor for this class doesn't seem like he plans things out. He kind of goes by feel. So I don't know what it's going to cover, to be honest. Yep, first graduate class in PD, and it's like at the PhD level. Or it's like the PhD track, which I've been doing for the other courses, like the core ones. What coffee blend do I like? I got this donut shop blend, and this chocolate caramel makes it yummy. I don't drink blends. I drink single origins. Computing strong solution? Maybe. I don't know. Okay, and since you invited me to do it, I'm gonna go grab the coffees that I have right now. So I don't normally have. I'm racist against coffee blends. I am. It is definitely cheaper to buy blends, but I really love coffee, so I spend a bit more on it because it's just a hobby of mine. And I don't normally have this much coffee around the house, but I'm definitely a snob. So I buy coffee where it all comes from the same farm. So the one I'm drinking right now, the bag is empty because I have it in a different container. This is one from Guatemala. It's all right. There's like even tasting notes on the back. So red grapes, candy apple, and caramel. The altitude that it's grown at, the variety of the plant. You just like the taste? Yeah, I mean, there's nothing wrong with the way that you enjoy coffee. I just am a snob who likes to drink fancy stuff. What's gonna be next is this one from Nicaragua. Ruibos Tea Cosmic Crisp. Wait, did I buy tea? This is it can't be tea. Why is there tea on the bag though? If I don't want to open it. Oh no. It's from do they grow tea in Nicaragua? It says cosmic tea or something Ruibos tea. I might have bought tea. I hope I didn't. I hope that's a tasting note. Uh, I do weigh my beans. In the water as I'm pouring it in. There is an actual thing you can buy to measure the extraction. I don't have that. That's a little bit too much, even for me. Um, I do also like have a kettle that can go to different temperatures. Like you can tell what temperature you want it to bring the water to. So yeah, so I have two other coffees that I'm letting rest. Oops. They're both from Say Coffee, which is like it's a pretty fancy place. Their coffees are like a couple bucks more expensive, but I've people on the internet post about them a lot, and I've really wanted to like try them for a long time. You have one of those too? Oh, nice. Do you do pour overs? Pour overs ever? Oh wait. Oh no, I got the cards mixed up. I hope. Oh no. If I got the cards mixed, I hope it says what it. Oh well. Wait. I hope I put the cards back in the right spot. But like they have all these cards like different like stats about the coffee and stuff. I don't know. I'm excited to try them, but they need to rest for a long time because when coffee is roasted, it has a bunch of CO2 trapped in it, and if you brew it right off roast, it's actually not good. So like, if you're drinking like medium or dark roast, it doesn't matter. The fresher the better usually. But for light roasted like I drink, you actually want to give it at least 2 weeks from the day it's roasted, but apparently for stuff like say that's super light, you want to give it like even like a month. You replace the water by vodka. You certainly could. Doesn't vodka boil at a lower temperature than water? I feel like it would. Or like alcohol in general. Let me put these away. Ugh. You have a pour over. You think you have every coffee paraphernalia. Jake calls my meth lab. Oh, nice. Could you, Skirtle? Isn't Liberica a big thing in the Philippines? Like Arabica is the most common species of coffee to drink, and then Robusta, and then Liberica is like the third, but it's pretty small. I don't know, Colicon. Hey, Quinn and Skirtle running into each other. You love to see it. Espresso machine, you can even put candy with your ground coffee for flavor. Oh God, yeah. I would never do that with my like nice coffee though. I think I was gonna say, oh yeah, I've done one coffee stream. If you're an OG, you might have watched it. It was a long time ago. Pretty sure it's still my YouTube channel. Let me find it. The Rick, yes, from a certain province here. My dad loves it. Oh, nice. I'd like to try it. Apparently, I wouldn't be very likely to like it from what I've heard on the internet, but I still like want to see what it's like. Oh my God. Here it is. And that's back when I used to wear collared shirts on stream because it would hold up my mic better. Yeah, a coffee YouTuber I like was doing like a big tasting. And these are just like flash frozen coffees that are like super concentrated, and you pour boiling water on them. You just have an instant like cup of coffee. And so there's a thing where you could like order a kit, and then once everyone has their kits, he does a live stream where you all taste it at the same time. And I was streaming me watching that stream. You love Arabica, but the typical variety from the mountains up north. Oh yeah, yeah. Drink Arabica, but it's Tim Hortons. Fair enough. Iberica Coffee Farm. Oh, that's so cool. It's a dream of mine to visit a coffee farm. There's one that I know of in El Salvador that like takes tourists. You know what? I'm just gonna I'm gonna show up one more thing on stream because we're on cut coffee now. Oh, from that same YouTuber, he made a poster, and it's like super nerdy thing to own, but it's like 6 different species of coffee, and like they're like illustrated by like an actual like botanical illustrator person, and it's like descriptions of the species. So Arabica, Coniferea, Eugenioides. Like 2 of these I hadn't really heard of, but Racemosa, Liberica, and Stenophila. Coniferea is Robusta. Like I think Robusta is just like a nickname. So yeah, that's one of the nerdiest things that I own, I think, about coffee. I used to have a lot of hair. I did F for my hair. I don't really miss it. Ooh, cool. That's where both my coffee beans from Say are from, from different parts of Ethiopia. I think it might be Kenya. Yeah, Ethiopia and Kenya are like the two like top in terms of like the quality of coffee. Those are known to be like two of the best places to buy it from. You lost a lot of hair. Yeah, I don't know if it's going to grow back or not. I haven't cut my hair this short since I was a kid, but I was getting really sick of having my hair be the length that it was. So just freaking buzzed it myself. And just like seeing all the men in my family, my hair kind of it was gonna go eventually anyway. Yeah, fair enough, Quinner. I haven't gone like full bald. I don't know how that would look on me, but April's coffee beans month for me. But when May rolls around, I get first harvest matcha. Oh, those 2 months you tell me hates you. Oh, that sucks. That your stomach doesn't like it. The matcha sounds great, especially. I think I did number 6. Oh, it should be on the other side of the equation. Ugh. Stop shaving your hair, you chicken. Don't just stop. It's so much easier to have short hair. Long hair is a pain. It takes forever to dry out of the shower. It gets messy. First harvest matcha hits different. I'm telling you, it also hits your bank account different. I bet. That's like my number one thing that I wish I did when I was in Japan. I didn't really try the matcha. There was a day, um, where I wanted to do like a tea ceremony in Kyoto. Um, but my friends were like, it was towards the end of the trip, and my friends were really tired and they were getting kind of like pissy, and I didn't feel like pushing it. I could have gone off myself and done it too if I really wanted to, but um, yeah, I wish I tried the matcha when I was there. If Don goes bald, I'll dye my hair toxic green. And by bald, I mean no eyebrows, no beard, no mustache, no hair. Well, to say, I'm definitely gonna be bald one day, like not by choice. But I hopefully I'll still have my eyebrows and my beard and my mustache. No nose hair, no eyelashes. Just my entire body completely bald. Not a hair anywhere. You know, hey, that'd be a good excuse to become a swimmer, right? Pluck my eyebrows for $100? Oh god, that sounds painful. Is it what is it? I don't want to try. No, never mind. You need tweezers to do that properly too. Oh wait, eyebrows. I was thinking of eyelashes. No. Eyebrows. I mean, it would hurt, but not that bad. Use a thread on my brows. Oh god. Um, I don't want to come back to number 5. I I don't want to do it. We I'm probably not going to stream for that much longer, but we can go back to the PDEs homework just for a little bit. See if we get inspiration for any of the problems. We should be able to get the answer for one, right? It's just an exponential. I had in my high school a math teacher with drawn eyebrows with a Sharpie. Oh, was that like how they always look, or was it like a temporary thing? Yes, it's how they always look. Wow, it's that's a choice of all the choices out there. Um, yeah, it's like I was even thinking in terms of like e to the minus ix or e to the ix. Surely it's just these, right? Yeah, it is. Um, they want real. Yeah. I mean, yeah, that is the thing. You can express a real function using complex numbers, but fine. You're right. Meow. Uh, so they just say a smooth function. So I could even just say sine of x, right? This is x is a vector. Does that that's still fine, right? That doesn't change anything. Oh wait, yeah, okay. uh, think yeah, that's better color cone. Do we need the m's? Can't we just keep it like this? Or you're just saying like a more general? In general, they're of that form. Okay. I'm okay with doing like a simpler thing. So just if n equals 2, let's just be sure this works. I mean, I don't know. Second derivative in terms of x1. The first derivative in terms of x1 is cosine x1 plus x2. Derivative of cosine is minus sine x1 plus x2. And then in terms of x2, it's going to be the same thing. Oh, this is off by a scalar multiple, isn't it? So we need to, like, it's 1 over n times all these, is it? Or 1 over root n? Or 1 over the nth root of n? No, 1 over root n. Yeah, okay, so this should give us what we want. Two derivative of cosine is minus cosine, right? I think this is the answer here. We can be even fancier and slap a cosine on there too. We can even put constants in front of the sines and cosines, but I don't know if that's worth doing. Now, I do assume there's a linear algebra way of doing this, right? I don't know exactly what, but like, surely this is like this is an eigenvector or something. I don't know. Is u Rn to R x to 0? What does x... Are you talking about like taking the limit as x goes to 0? Just u of x equals 0. Oh. Yeah. I don't see why not. It's definitely not their intention, but I think u will equal 0. It would satisfy it. It would just call it a trivial solution. That'd be funny. Like, they don't exclude that. They're probably looking more for an answer like mine, but yeah, but that's a funny thought. Syntax. Or are so many variables, can you just take the projection to the first coordinate? Oh. um yeah, uh no, you're right, Syntax. I think that's a lot simpler. Like just chopping off these variables entirely. That was your cosine of x1? Oh, okay, okay. I that is a lot simpler. It does feel like cheating when it's not like it's only technically function it only technically takes Rn as the input, like doesn't really. Um Hey, would that be smooth? Or yeah, is with that projection they are smooth? Okay. Yeah, that I still like my answer, but I that's probably valid also. Derivative of the projection function just one, or is it not continuous? I don't know. Jacobian is the projection matrix to the first coordinate. Is it? I don't know what to think of that. Linear functions are always smooth. The Jacobian is just the linear function. I guess? I don't know. When y changes, the difference is 0. I guess it'd be like... I guess it'd be 1. I guess... I guess you'd have to talk about, like, the derivative in x? I don't know. We don't necessarily have to do 2. I'm still a little bit weirded out by 2. What else is on the PDE agenda? I need to switch notebooks. This is the wrong notebook for PDEs. I feel like I haven't done multivariable properly either, syntax, as I'm finding out from learning about PDEs. Yeah, 3 makes me nervous because I didn't understand the proof that we did in class. We can look at it, though. So the proof from class was Liouville's theorem. That would make sense if we use the mean value theorem. I still need to figure out what I still need to read what the question is saying. Yes, next error. This is just like homework. It's always like the last priority if you want to ask a question. Show if it's harmonic and not constant, it grows at least linearly. There exists a constant C0, C greater than 0, such that for all R greater than 0, the maximum... Is that what linear growth means? So let me, I guess let's start by thinking about the proof from class, and I'll repeat what I have written down here. There exists a C greater than 0 for all X in Rn such that U is bounded by C. Then U of X equals alpha, which is just a scalar. So the intuition of this is that there is no interesting bounded harmonic function. Or at least that don't grow at infinity is the exact term. And so the proof for this that we did in class, just a sketch of a proof. Okay, let's switch to syntaxes. Question. Oh. If x maps x to y, that are metric spaces. I don't know what that means, but I can go with it. Be a function, or I know of metric spaces, but making your sphere bigger and obtaining contradiction. Okay. Uh, be a function in A and X. Then the following conditions are equal. F is continuous at A. If A sub X and A in the closure of A, dividing by the sphere area and the mean value property. Yeah, I didn't understand this part of the class color code, so I'm not going to understand that right now. If A sub X and A in the closure of A sub X and A in the closure of A, then F of A in the closure oh ha. I was wondering what A sub X was. Do do we know that small a or a might not small a might not be in big A? We have security dogs here in Atlanta. Like where? Like at the mall or in your house or like what kind of places? Patrolling the streets? In businesses? Huh. I mean that I can see that, I guess. Be able to prove this without invoking anything about metric spaces. That'd be nice because I don't know anything about metric spaces personally. I brought that page up, color code, but I'm not going to look at it right now. Um, Using the city though, out in the streets, huh? Well, hopefully it helps. I guess I don't know. Hopefully the dogs don't attack the wrong person. Probably going to be the biggest issue. Fizzbuzz, hope you're doing well. Oh wait, if A is a subset of X, oh my god, I was completely misinterpreting this statement. Um, okay, A capital A is subset of X, and then A is an element of the closure. Oh my god. Okay. Gold. How about imperial spaces? True. It's the kind of space I enjoy. Um, What is the second statement telling us? Yeah, I'm doing all right too. Oh, they're coming up with the Darth Maul series. That's cool. I've seen barely any Star Wars. Like I've seen the original six. I've seen Rogue One, and I think I've seen like episode 7, maybe 8. I've never been a big like Star Wars person though. I've heard a lot about Andor. That's like one of the best ones. I don't. I've never been much of a Star Wars person though. I don't know why. Like it's fine, but um, I don't know. Not even a Trekkie either. I I. I'm not a huge sci-fi person in general. Like I like it, but it's not my favorite, I guess. Fortnite definition of closure. I thought closure is the closed version of an open set. Like the closure of 1 comma 2 is 1 comma 2 like that. Smallest closed subset that contains your set. Closure of Q is R. Oh, okay. Oh, sorry. Max asked that. Sorry if I said syntax. Same color. Tried asking my ex, she gave a vastly different answer. Lacking remorse. Thank you, thank you. We could all use some closure sometimes. Closure of A is equal to all x and x such that all neighborhoods of x meet A. Is in your book. You set A plus its limit point. Okay. Oh, right. Yeah, I think I've heard it described like that. Now that you put it like that. I sort of know, like, so if we have an element, A is basically just some element of X, of the domain. The value of the function at that point in the domain should be within uh that domain. The range. So okay, if this is X and this is a bar, what we're saying is that um this A bar region, it's like A with a unibrow. I don't know why that's where my mind goes. I don't know if this is really a helpful drawing. Neighborhood is an open set of X containing A. Yeah. I know in this context it's basically like A with its boundary. I think you got one direction. I don't think you have the band one direction. You don't own them. Color cone. We made the same joke syntax. Uh, let E be closed in Y, then apply 2 to F inverse E. Let E be closed in Y, then apply 2 to F inverse E. You get the closure got mapped to E. But that implies F inverse of E is closed. Huh. So we're considering E is a closed subset in Y. F inverse of E. Two implies uh so you're doing like an F of F inverse thing. With F is continuous at A, not necessarily everywhere. You think of the global statement. Oh. If that's the answer, I'm definitely not going to come up with an argument like that myself. Or if it's something like that. um so is it saying a closed subset of the domain maps to a closed subset in the range? That's what 2 is really saying. F of A might not be closed, even if A is. Well, aren't they saying the closure of F of A, right? I feel like I've done this before, now that I think about it, but just in a different context. Or like I've heard about this. Um, it's always hard to like. I don't know. F doesn't necessarily map closed to closed. It could okay. It still could be open even if it's inside of the closure. I mean, even if the actual set isn't closed, like the range is still closed. I guess maybe what I was thinking. Like I guess like an image versus or yeah, like the difference between image and range. I don't know. This isn't my like this isn't the type of math that I'm good at. um Hey Leo, counting closed embeddings, we have a lot of closed maps. All right, Leo, we're just trying to do the question on the screen. Um, I'm getting to the point of Googling it though. I I I I I kind of want to Google it and see what comes up. I won't show it on the screen in case Syntax doesn't want a spoiler, but just want to understand it. Okay. Your topology class. Okay. So I will. This is the first thing that came up. I don't know if this is the same thing as what you have. I think it is. Yeah. The compliments sure haven't. In a global setting, no. It's not the same. Okay. Um, I still want to see what this is talking about though. Oh, they're only asking about if B then C, and we don't care about C. Max is saying 1 to 2 can maybe be done like this because closure is the set and its limit points. A is in the closure of A implies there exists A sub n sub n. Yeah, like you have a sequence that converges to A. F of A sub n is a subset of F of A. And limit fa n equals fa, then fa syntax hasn't gone over limits in topological setting. Ooh. For any property involving closed open sets, you can make an equivalent property by taking the complements of things. Uh, that sounds right, Leo. I'm not good enough at this type of math to know what to do with that though, or how to do that. So I'm gonna keep looking at this. You cannot use limit for general topological space. Okay, this is the answer that they said, but let's. What was the question? Okay, so this is like the global statement again, but maybe the idea will be helpful. Uh, there. C is close in Y. And it's probably basically color cones argument, actually. I think it is. Um, taking common using the open set. Gonna work fine here. It's all. I'm sorry. I think I'm way out of my depth here. I don't get what's happening anymore. Sorry, syntax. Um, I don't know how to do this question though. You know that's a legitimate strategy in math. Just sleeping on it. I do that a fair bit. What's the question, Leo? Why do we need complex numbers? I mean, I assume you already know a lot about them, but like from my perspective, one reason is that they're really good at representing periodic things. Um, so like Fourier series are super important in a lot of applications, and those are kind of at least best done with complex numbers, or you can only like define them via complex numbers. I mean, you could just like randomly define it in a vacuum, but you wouldn't know where it comes from. Um, Same with like the Laplace transforms and solving differential equations. Yeah, and even you wouldn't know where the sines and cosines come from, or like you wouldn't be able to like justify that you can represent so many different functions without complex analysis. Um, so yeah, I think of complex numbers being like the most helpful for like, because that's what I study, like differential equations and evaluating integrals. Um, like even for like asymptotics for real valued functions, you can sometimes use complex analysis there because you end up with like integrals of things that are difficult to evaluate. I know they also show up in like number theory. Um, but I don't know that I don't know much about number theory. I think like the Riemann zeta function and stuff like that. I think complex numbers have something to do there. So yeah, I don't know. Another question? Okay. Yeah, I don't know why that's there either. Color cone. I was gonna start writing through the proof that we went over in class for this. What about negative numbers? You don't trust them? I mean, I don't know. It's helpful to have an inverse up, like an inverse for addition. You can do a lot more interesting math if you have them. Thinking, assuming u of 0 is not 0, should probably do up to by adding by a constant. Yeah, but I mean, like, I guess, um, I guess I mean, like, maybe like the group theory sense. Like, if you're gonna talk about like the, I think you can't make a group of like natural numbers under addition, right? Because they don't have inverses. Show me -3 apples, math man. Okay, I'll break into your house and steal 3 apples. Well, yeah, you have -3 apples. I have +3 apples. Well, go buy some apples quickly. Hey, Roxra, I'll show you robbery. I mean, you could owe someone 3 apples. You could be in apple debt. Complex numbers, yes. Negative numbers, no. Yeah, let's. That's like that. That's a chaotic version of math right there. Um. So the proof of this that we went over in class, we just did it in 2D for simpler notation, but it's apparently like literally the exact same in higher dimensions. Just the notation's a little bit more annoying. I think you consider u of x minus u of y. Uh, oh yeah, so we're considering x and y close together. Oops, that's definitely a y. That is a branch cut. Oh, I guess so, yeah. And we're going to consider neighborhoods around x and y. That looks terrible. Yeah, that's what's gonna happen. Color cone. A third question, okay. So by the mean value theorem, it's equal to 1 over r squared pi bxr, dummy variable u of z dz, minus 1 over r squared pi u of z dz. Oh, that's y. Sorry. What are real numbers, though? The closure of the rationals? Don't test me on that, though. I haven't actually done that for myself. Okay, well, I do know in general that you can... It's all the rational numbers plus all their limit points, because irrational numbers just the limit points of rational numbers. It's like on the last two clues. Oh, no. You're free? Free of what? Your chat wasn't there? Oh. Welcome back, then, Roxra. Well, because pi isn't rational, but it is the limit of rational numbers. With these two integrals, the stuff in the middle just cancels out completely. And so there's really only a two-region story about R that we'll name R and L. So we end up with just U of Z dz over L minus the integral over R, U of Z dz. Captain your school's USAD team next year? Ooh, hell yeah, Roxra. I sure am, and apple pie is well known as the most irrational of pies. If you do the triangle inequality like 3 different times, you can get to this statement. At least 3 times. We are sad? Is that an acronym, or are you actually sad? Oh, the you sad team. Okay, you're responding to Leo. Yeah, feel better. Very important. Slay the Spire 2 to play. That is very important. Godspeed to you, Leo. The proud man counts his newspaper clippings. The humble man his blessings. Ooh, Skirtle, you finally get it. What? Okay, it doesn't predict the future, but that's still wisdom. I'd be happy with that fortune. I think that's a good one. You do work with newspapers. Ooh. It double fits then. No worries, Leo. This proof is in 2D, but the only thing that would change, it basically works for any dimension. The only thing that would change are these factors out front. If we did it in n dimensions. This is the part where uh we approximate L, the area of L, with a fucky rectangle, and same thing with R. Um, and so we said that the area of L is bounded above by some constant times R times the magnitude of X minus Y. The magnitude of X minus Y is like that length there, and it's like the biggest this gap can be in this direction. Yeah, a messed up rectangle, but a rectangle. And then the R, it must be this length here. I don't know exactly how. I guess like there's a 2R in there, but it's absorbed inside the constant. Clonk. Borrowing is not much better than begging, just as lending with interest is not much better than stealing. No PS5 Pro that I guess. True. Borrowing is not much better than begging. Lending with interest is not much better than stealing. That's a very opinionated fortune. I don't know if I agree with that one. Borrowing is not much better than begging. That's a really harsh statement. I don't know. Um, in the area of R is actually bounded above by the same thing somehow. I guess it kind of makes sense because these distances are the same, the R is the same. I don't know why the constant should be the same, but you can always take the maximum of the two constants, I guess, if you care about that. So it's bounded above by... Oh, why do we do that? By the area of L plus the area... Oh, right. Okay, so we do... Oh my god. Okay, so I didn't get this during class. So the thing we wrote next is C times the area of L plus C times the area of R. But I think these C's are different than these C's because these C's are the maximum value of U that we're assured exists from this. Okay, that makes sense. And then we can use these inequalities and just match all the constants into one giant one that we also call C. 1 over R squared, or C over R squared pi, times technically 2 R x y, x minus y, but the 2 will be inside of the constant. And the point is, these are all constants except for the R. So it's approximated by 1 over R. And the thing that I don't get, that I still don't get, is why does this result imply that U is a constant? I don't think if he did explain that, I missed it. So what we've said is that the difference between two nearby points as we make the balls bigger, scales with 1 over R, or smaller, you can take R to 0, independent of X and Y. if we do that, isn't the difference between them getting infinitely big? What? R to infinity, okay. Because this has to be valid for all R, so taking R to infinity is convenient? Or not, like, maybe not all R, but all R that's big enough. Yields U of X. Oh, okay. Yeah, I wish he said that. If he might have said that verbally during class and I missed it, but he definitely didn't write on the board. Okay, and so that means U of X equals U of Y. And that can only be true if it's a constant function. In general. But that can only like generally be true if it's a constant function, I guess. Okay. Okay, so this is the proof they're asking us to modify in problem 3. Do something simpler. Okay. Grows at, so this time it's harmonic and we're guaranteed it's not constant. It grows at least linearly. Greater than 0. The maximum value of U inside of a ball of radius r centered at x is greater than some constant that depends on r. Well, that a constant that depends on r is a weird way to phrase that, but some linear function. So as you make the ball bigger, the maximum also increases at least linearly. Making a big ball around 0. I mean, I bet you could always do like a change of variables to center it at 0, if that's convenient. I mean, we probably want to apply the mean value theorem, like apply it to the U inside of here, and then hopefully do something. Mean value property, I think, is more accurate to call it. What were we calling the constant in class? I think it was just C sub n. Yeah. not doing this right. Then presumably want a triangle inequality on the integral? Well, wait, this would give us a smaller thing. No, a bigger thing. Is this maximum bounded above? I don't know if this is going to be a valid statement, but let's write it and see how it makes us feel. Does that feel true? Vibes only, no math allowed. Yes. I feel like I should maybe swap these around so we can still see the original problem. Oop, what did I just do? Want to bound from below. We sure do. I definitely believe if I mess this up. Okay. Yeah, this inequality is going the wrong way. True. I mean, to be fair, I don't even know this inequality is true the way that I wrote it. I know that if the thing I don't know is like if the maximums affect the inequality. If you remove them, I know it will be true. I think it would have to be true. I don't know. It's hard for me to judge. We know U is harmonic and not constant. So I wonder if we do want to consider 2 points again. Well, I don't know what that would look like though. I don't know what the end game there would be. Make more coffee? Enjoy. Oh my god, it's almost been 5 hours. My voices? Is it my microphone or just mean like me? Testing, testing, testing. Okay, no, my mic sounds fine to me. Sorry if you're hearing me twice. Oh, okay. You're sick. Oh, okay. Sorry. No, I do the same thing where I'll just like make a statement without saying like yours or mine. And I've had people like had the same confusion, so I get it. I hope you feel better soon. Dude, I feel like every time I start the stream, I'm gonna be like, okay, the stream is just gonna be like 2 hours so I can get, get some rest after. And then I look at the time and it's been 5 hours. Actually, wait, has Dr. Gold started yet? Just so we know he has. Okay, good. Um, mm -mm -mm. RN to R. Adapting the proof from class. Uh, ironically, not from class, but those are the next two questions. So I would be okay personally with using a result from one of these problems. I hope that that'd be allowed. Just wondering, is it in the book? Mollifier? That was a mollifier. They describe it in Appendix C. What the hell? Oh, I'm glad they explained that. I'd never seen that double subset thing. Yeah, this is the textbook for the class. Oh, we do weak solutions. I mean, why not cover it? We've already been skipping around in the book a little bit. Yeah, this is this is apparently like a really standard textbook by Evans. I don't know what we're gonna cover out of it. question, it did say to modify the proof, yeah. So I guess we know that U is not bounded. Okay. Maybe you mean of the proof in class? Uh, so I think from Liouville, we can know that U isn't bounded from above. Uh, it's just about the rate of growth. That's what we're really trying to prove something about. I wonder if we somehow need to show that the... I guess that means this integral must grow at a rate n minus 1? Hey, girl that is small, welcome in. How's it going? How do we make that claim? Oh, mine kind of goes to like Taylor series. We did use Taylor series for something else in class. Too much? Your favorite system in math? What is that? The arrow system. I need to Google that. Oh, I'm seeing missiles. That's probably not that. This could be a few things. So I'm not sure which one exactly you mean, girl that is small. I've heard of arrows impossibility theorem. There's also like arrows as in like vectors or like using them to think about addition and subtraction. And then okay, so it's probably like this sort of thing for tetration. Let me just it is that okay, yeah. I have seen these before. I have never done anything with them or Yeah, you call it the arrow system. Fair enough. Yeah, the notation quickly kind of gets away from me for like what this actually means. As far as I know, it's like maybe kind of fun. I don't know what it's useful for. But yeah, I've heard of this at least. I can't say that much about it though. For Google, oh, I never heard that term. That makes perfect sense though. People who study very large numbers. And here's Graham's number. Do you use this for like a certain thing, or do you just enjoy kind of like the puzzle of representing big numbers? Can we do something like ux sub n minus u0, where x are the maximizer of u? uxn minus u0, xn is the maximum value. U of 0 equals 0. It's more like argmax because it's the actual x value. It's fun to think about. It keeps me steady mind-wise. Fair enough. Yeah, it's not like something that's interested me that much, but before, but more power to you. I wish I had something smart to say about it, but I don't know very much about all that arrow stuff. Um, yeah, and girl, let us know about. But whenever I see a new person, I'd like to let them know. If you're interested in math streams in general, it's not just me who does this on Twitch. Pretty soon I'll be raiding over to another actual education, and I'm not saying like go watch every single person in this list, but I just like to let people know that the niche does exist here on Twitch. That's what the point of me kind of showing this list. um, but yeah, like welcome in. I'm getting towards the end of the stream, so I'm getting like tired and running out of things to say, but appreciate you being here and saying hi and sharing what your interest is. Um, Roxra, what will quadruple integral do? Basically the same thing as a double integral. It's just it'd be in four dimensions, so it'd be difficult to visualize. Um, but like the way to think about it is a single integral is the area under the curve in 2D. A double integral is the area underneath a surface, or sorry, the volume underneath a surface. So like whatever's between here and the XY plane. Um, and then after that, it gets harder and harder, or you can't visualize it at all. But it's the same sort of concept. Like you're getting volumes in higher dimensions, basically. Oh yeah, I mean, if you'd rather keep it to yourself, that's fine. But if you feel like sharing it, please do. I can't promise you that I'll be able to understand it or say much about it, but you're welcome to share it if you'd like. um, struggling enough just to keep up with color cone right now. So, almost certainly not Rookshire. I can't imagine what that would be for. Is n just like some indication of a sequence? I assume it's different than the n we're using for dimensions. Yes? Okay. Hey, Suna. It's going good. How about you? Just getting towards the end of the stream here. I'm doing it by contradiction. Um, yeah, this one's a bit of a doozy. This is I just started with a PDEs class, and this is the first homework assignment. Oh yeah, that's completely fine. The NNN system. Hey, uh, fair enough though. I'm glad that you're like exploring math in the way that you enjoy. Yeah, I really want to learn about PDs, so in that sense, I'm excited for this class. It's already even on the first day, it was very difficult though. We know that subharmonic functions still have the maximum principal, and I guess that's kind of the main thing. U minus CR? Oh. And so it's equal to a constant? Or greater than a constant? A negative constant? Hopefully. And do subharmonic stuff. Hmm. It's an interesting thought. So I don't know what the next step is after this, but either. Yeah, I don't know what to do with this proof that we were given. Yeah, I've been kind of puzzled about this too. I mean, it sort of makes sense that it wouldn't go in the right direction. because we are specifically removing that restriction. But yeah, I guess I don't know how it's going to be helpful because of that. I know. I think this might be a good spot. Oh, to call it, but let's see what Girl Let Us Smell said. The basic is that the middle n is the result of the first n and n. And well, n and n equals n. Take that n, put it in the middle of the n and n. Huh. Are there supposed to be like up arrows between these ends? Or I don't think I'm following that. I have also been doing math for 5 hours now, and I'm getting like mentally tired. The middle end is the number of arrows. Oh, okay. Linus de Milo, thanks for the follow. So maybe I sort of follow. I guess it's almost like you're making the notation even more compact. Maybe. I do think I want to call it here though, because I'm at my limit of thinking for a while. It goes deeper. Yeah, no worries. It's really hard to express your thoughts in a Twitch chat. It's just I get it. I've tried to talk about math for uh just like through Twitch chat before, and it never like quite comes out right. Thank you for trying. Um, so yeah, I'm cut the YouTube stream off here. So anybody's here on YouTube, thanks for being here. On Twitch, we're gonna raid out.